Good morning, everyone. Welcome back to science class. Today we are starting a new topic, and our topic today is types of forces. In this unit, you will learn how to define forces, what are the types of forces, measurements of forces, and how to calculate work done. Today's learning objective, we have two, which is the introductory part of forces. So we are going to state that a force is a push or a pull, and we're going to identify the different types of forces, for example, friction, force of gravity, and magnetic force. So forces, the first part is how to define them and how do we use the term. So what is our step to success? Firstly, for this learning objective, which is state that force is a push or a pull, we need to define force. And secondly, we need to include in that definition that forces can be a combination of a push and a pull. So it's a very simple step to success. So what is a force? Forces, or a force, can be, again, a push, it can be a pull, and it can be a combination of both push and pull. For example, bending or twisting. There are other examples of types of or forms of forces, and these are all these can be classified as a push or a pull. For example, twisting, lifting, squeezing, stretching, kicking, turning, slamming. I hope you don't slam anyone like that. And even bending. So all of these are considered as a push or a pull, therefore they are considered as forces. So what are the types of forces that we need to learn mainly? Firstly, it's friction, and then we're going to talk about force of gravity and also magnetic forces. So our step to success is to state the three types of forces. As long as you guys mention these, then you are pretty good for the day. And give examples of the importance of each type of that force. So main example of forces that we have is firstly gravity. Secondly, it's friction. And thirdly, it's the magnetic type of force. Again, let me remind you guys that a force is a push or a pull. So every one of these types of forces have that kind of push or pull type of thing going on. So firstly, let's look into gravity. Gravity is a force of attraction between masses. So when we talk about this, force of attraction is basically pulling masses together. And gravity is also a property of mass. The bigger the mass is, the bigger the gravity. So remember, we learned about the word mass, and mass is how much matter something contains. So the bigger mass is, so much matter that thing contains, then it has a bigger force of gravity. And force of gravity is a force of attraction between masses. Mass is a measure of the amount of matter in a body, and the weight of an object is a force of gravity pulling on that mass. So weight itself is actually a type of force. So how do we calculate weight? Weight of an object is when you have the force of gravity and it pulls down on that mass. And this is calculated with this formula: weight equals to mass of that object times the acceleration of gravity. So weight, how do we calculate weight? We have the SI unit for weight, which is in Newton. And the mass of an object, we calculate that using the SI unit of kilogram. And acceleration of gravity is usually constantly either 10 meter per second square or 9.8 meter per second square. So if you're looking to calculate weight, which is a force, we take the mass of that object times acceleration of gravity. For example, teacher's mass is about 52 kilograms, and my weight will then be 52 times 10, so 520 newtons then. or 530 newtons. I need to check. Anyway, so if we want to calculate weight, we can remember it using this formula, W equals to mg, or we learn about this triangle. So we put W at the top, m and g side by side. So what this triangle actually refers to is that at the bottom of the triangle, that means divide. And if you're next to each other, you times each other. We're going to learn about how to use this triangle in the future. So this is just an introductory for you guys to remember. For now, please try to recall that weight, which is a force, equals to mass times gravity. So what is the importance of gravity? This force, gravity, keeps us from floating away into space, especially when we jump into air, because we are basically on this huge mass, which is the Earth. And all of us, we are made up of matter as well, so we contain mass. And remember that gravity is basically a force of attraction between masses. So we are actually being pulled towards the Earth, and it helps us to pretty much stay on Earth, and so that we don't float away. Secondly, when you kick something, it always falls back to the ground because of gravity. Thirdly, Earth's gravity also keeps the moon in place. Without gravity, the moon will also float away into space as well. Alright, let's look into the next force, which is friction. Friction is a type of force that is between two surfaces. So just now we had gravity, which is between two masses. Now we're looking at between the surfaces. So surface is basically anything like on the top. So if you are actually watching this video and you are and you're at a table, if you just touch the surface of the table, that is the surface, and there is friction there. Because any time where there are two surfaces that are touching each other, then there is friction. And friction is a force between two surfaces that prevents those surfaces from sliding or slipping across each other. Friction is a force that opposes motion. That means that if something is moving on top of that surface, friction is a force that would be the opposite of it, that will go against it. So if you have rough surfaces, then there are more friction there, and smooth surfaces would produce less friction. So again, here is a diagram to show you the fact that if this box right here is moving in that direction, friction is a force that moves in the opposite direction. And friction will increase if the surface is rough, and there will be less friction if the surface is smooth. So for example, if you are on top of snow has a lot of ice on it, and it is very, very smooth. So that's why this little penguin here can go pretty fast. There's less friction at very smooth surfaces. Why is friction important? Without friction, firstly, between the ground and the soles of our feet, we wouldn't be able to walk. We would be slipping all the time. So here's a very good GIF about friction. So there are two surfaces here, that box and also the ground. And you can see here that the ground is pretty rough, and that box is made out of wood, and it is pretty rough as well. So you can see that it moves not very fast. It doesn't slide, but it moves very slowly because the force of friction is opposing the motion of the box. So it's moving in the opposite direction of that box, the motion. Okay, secondly, friction helps to keep the wheels of a car on the road and slows down the car when brakes are applied. This is super important for our safety. That's why for people, especially in this country, we need to always change the tires if we are driving, like you guys maybe, before COVID, if you guys need to go to Bandar all the time, especially, then your car tires need to be changed as well. Okay, the disadvantage of friction, we're going to learn about that now. So if we have a lot of friction because of this opposition of the force on two surfaces, it can lead to wear and tear. Wear and tear means that if there's friction for a long time, it's going to cause damage to those surfaces. Firstly, you can definitely see this, especially in your school shoes before COVID. If you guys can check underneath your shoes, your school shoes, you would see that some surfaces have already worn out. It has become much more smoother, especially at the sides, because these sides are always touching the ground when you're walking a bit in between classes, and it is worn out because of this force of friction. Secondly, friction causes moving parts of machinery to wear out, because parts of machinery, especially gears, they are always having this contact between each other, and when they do that, then they can also have wear and tear, and they wear out. So, and friction itself as well produces a lot of heat, and that also can cause damages to all of the gear and moving parts of machinery. So how do we reduce friction? Because friction can cause a lot of damage to surfaces and it gives off a lot of heat, we can reduce friction by a few things. Firstly, use wheels. Secondly, we can use lubricants which help to smoothen surfaces and reduce friction that way. Wheels can reduce friction because of the smooth surface as well. And thirdly, using air between interacting surfaces. This is called a hovercraft, and although it looks like it's moving on its own, but of course it is, but there is actually a layer of air in between this hovercraft and the ground that makes it being able to move across the water and onto the ground as well. Okay, thirdly and lastly is a magnetic force. Magnetic force or magnetism is actually the force of attraction and also force of repulsion. So remember, push or a pull. So attraction here is the pull, repulsion here is the push. And this can happen by magnetic materials, for example, iron and steel. Magnetic forces, they always have, or magnetic objects have a north pole and a south pole. So every magnet has this. So they always have at least one side that is north and the other side would be south. So it really depends on which part it is, in which direction we're looking at here. So we have a north and a south here as well. Sometimes it's not even that labeled. For example, in a disc magnet, we can't see where the north and south is, but we can, for example, use a magnet that already has a north and south pole labeled, so we can see if it attracts or repels. Then we can find out whether or not that magnet contains, or which side of that magnet is a south or north pole. So these are just examples of magnets. That's a bar magnet. This is a ring magnet. That's a horseshoe magnet. This is a magnetic needle that you can actually find in compasses. And you have a disc magnet over here. So magnetic property, it can either be a force of attraction. So different poles would attract. So let's see this GIF again here. North and south would attract each other. So different poles attract. And this is a force acting between magnets called the force of attraction. Okay, so for example over here, they're attracting each other. That means that the surfaces here, they are actually unlike poles, so different poles they would attract. The second type of force in magnets is called the force of repulsion. So like poles, so poles that are the same, they repel. So you can see in this GIF right here, the top, north and south, they push each other away. The force acting between magnets is called the force of repulsion. So you can see right here, these two magnets are pushing each other away. That means that they both have like poles. That means the same type of pole. So what is important about magnets? Magnets are important for daily purposes and also some other big purposes as well, but we're going to look at the daily ones today. So firstly, magnetic buttons to hold notes. So this is a daily use of magnet. We have magnetic door stoppers that help to hold doors open so that you don't slam your door. So if you can see at the top here, that is the magnetic door stopper. You have handbags and purses that have magnetic fasteners to open and close them, and this is something you can see pretty much if you have like these type of bags. They actually contain magnets as well to hold the purses together so things don't fall apart. Alright, now that we're done with our lesson, let's look into our step to success again. So you have to define the definition of force and also include the fact that it can be a combination. So the force is a push or a pull, and it can even be a combination of a push or a pull, for example, bending or twisting, or all the other ones that we talked about, like squeeze and turn and kicking as well. So secondly, the three types of forces we need to mention is force of gravity, friction, and magnetism or magnetic force. And the importance of each type. So we have gravity. Gravity keeps us from floating away into space. Every time you kick something, it falls back onto the ground. And it also keeps the moon in its place. Secondly, the importance of friction. Without friction, the ground and the soles of our feet, we won't be able to walk without slipping. And friction helps to keep wheels of the car on the road. Thirdly, example of the importance of magnetism. Magnetic buttons hold notes together, magnetic door stoppers to hold doors open, and handbags and purses have magnetic fasteners to open and close them. So these are examples of daily importance of those forces. And that is the end of our lesson today. I hope you guys have a great day today. Stay safe, everyone. Bye!